Hello, welcome to this DevTV presentation on Introduction to AutoCAD Civil 3D.NET Programming. My name is Partha Sarkar and I work for Autodesk Developer Network team, that is ADN team. I am based in Autodesk Bangalore office and I work on application development covering all the APIs of our infrastructure modeling and geospatial applications like AutoCAD Civil 3D, AutoCAD Map 3D, Autodesk MapGuide Enterprise, and TopoBase. In this recorded API training video, I'm going to cover the basic concepts of using the Civil 3D.NET API. I'll demonstrate how to create a .NET project which uses the Civil 3D.NET API and access the Civil application and document objects to retrieve and modify Civil 3D entities. I'll also demonstrate how to use COM Interop from .NET to access Civil 3D objects and functions which are currently not available in the .NET API. In AutoCAD Civil 3D, objects are the basic building blocks that enable you to create design drawings. The underlying program code for AutoCAD Civil 3D uses an object-oriented architecture. As a result, design entities in the drawing, such as points and surfaces, are intelligent objects that maintain relationship with other objects. For example, if a horizontal alignment is modified, any profiles and sections based on that alignment are automatically changed. The primary AutoCAD Civil 3D object types that enable you to create civil engineering design components and the icons that represent them are shown in this slide. These types of objects are sometimes referred to as graphical objects or drawing objects because when you use them, a graphical object or shape, for example a pipe network, a surface or a corridor, is inserted into the drawing. AutoCAD Civil 3D objects automate the design process by interacting with other AutoCAD Civil 3D objects. A design team typically spends many hours ensuring that revisions are transferred correctly between the surfaces, alignments, profiles, sections, and other design data. Redrafting, relabeling, checking the work can be time-consuming task. Civil 3D eliminates the need for most of these tasks by introducing dynamic links between design objects. This system of links and dependencies derives from the object model within the application design. The diagram shown here illustrates how Civil 3D data objects are related to each other. Changes to any object flow downward along the arrows to dependent objects with a predictable results. For example, if you correct the elevations of an existing ground surface, updates flow to any related grading objects, pipe networks, corridors, and profiles. As a result, all values represented in labels and tables are also updated. Let's now check what APIs are available to customize and extend AutoCAD Civil 3D. In general, there are 3 APIs available for customizing AutoCAD Civil 3D. .NET API allows us to write extension to Civil 3D in any .NET language. In most of the cases, we have seen that Civil 3D.NET API performs significantly faster than the COM API. Using COM API, you can create clients that access the COM API from managed .NET or unmanaged C++ code. In addition, this API can be used in creating VBA macros. However, at this stage, we would suggest you not to use VBA as VBA support is deprecated. Custom Draw API is an extension of the AutoCAD ObjectRx API that allows you to customize the way Civil 3D renders objects. Okay, let's get started by creating a simple Hello World application using VB.NET in Civil 3D. After that, I'll discuss about some basics and fundamentals on Civil 3D.NET API and how to create or access various Civil 3D objects in a .NET application. In our application development using .NET API, we need to start a new project using Visual Studio with any of the .NET language of your choice. If you want to build a .NET application for Civil 3D 2011 or 2010 release, you could use Visual Studio 2008 or 2005. In the next step, you need to add reference to the managed assemblies for Civil 3D and AutoCAD. For that, you browse to the install directory of AutoCAD Civil 3D and select the base libraries acdbmgd.dll, acmgd.dll, aecbasemgd.dll, and aeccdbmgd.dll. Please note that these are the base AutoCAD and Civil 3D managed libraries. Your .NET assembly can use classes defined in additional libraries too. To allow debugging and reduce the disk space requirement for your project, you should select these libraries in the Visual Studio Solution Explorer and set the copy local property to false. Little background information on why we need to add reference to aecbasemgd.dll when all the Civil 3D functionalities are housed in aeccdbmgd.dll assembly. Autodesk.aec.databaseservices.entity is the base class for Autodesk.civil.databaseservices.entity, which in turn is the base class for most of Civil 3D entities. This design mirrors the architecture of the DBX core and the entities declared in it. Since Autodesk.aec.databaseservices.entity is implemented in aecbasemgd.dll, a reference to this DLL must be added to your project. In the next step, in our project setup, we need to import the namespaces we are going to use. In VB.NET, we use the imports keyword to import the necessary namespaces. At the basic level, we need to import certain AutoCAD namespaces to access the AutoCAD application, AutoCAD editor, and runtime for command registration, accessing the editor, etc. To access the various Civil 3D objects, we need to import the appropriate namespaces. Reference of these are available in detail in the Civil 3D.NET API help file. This slide shows a typical Hello World code snippet with a very simple command to print Hello World message at the Civil 3D command line. I'll explain the code sample in detail shortly when I demo the steps using Visual Studio. Launch Visual Studio and then select File, New, Project. In the New Project dialog, select Visual Basic for the project types and select Class Libraries under Template. Give an appropriate name to your project and place the same to a location of your choice. Next, click OK to complete the creation of the project. In Visual Studio IDE, make sure the Solution Explorer is visible. If you don't see it right here, you may need to turn it on by going to View menu and selecting Solution Explorer. Through Solution Explorer window, we can easily browse through files in the project and add references to the required assemblies. At this stage, let's add references to the AutoCAD and Civil 3D managed assemblies. I'm using Civil 3D 2011 release, and let me browse to the Civil 3D's installation folder. and add reference to acdbmgd.dll, acmgd.dll, aecbasemgd.dll, and aeccdbmgd.dll. If you notice here, the copy local attribute is set to true by default, which we need to change it to false. Now that we have the classes referenced, we can import them. In vv.net, we use import keyword and import the necessary namespaces in our project. We import autodesk.autocad.application services to access the AutoCAD application. We import autodesk.autocad.editor input to access the AutoCAD editor, and we import autodesk.autocad.runtime for command registration. Now in our class, we need to define the command that we are going to run when we load this application in Civil 3D. To add a command that can be called in Civil 3D, we use the command method attribute. This attribute is provided by the runtime namespace. Command method attribute type accepts several parameters in its constructor, such as group name, global and local names, command flags, and more. Next, define the sub, the command name string, and the sub names can be completely different. Also notice the use of the line continuation character. Now let's start writing the code. Our intention is to print a very simple message, hello world, at the Civil 3D command line. We first get the editor object for the active document. When the hello command is run in Civil 3D, the hello world sub will be called. In this sub, we get the instance of the editor class, which has methods for accessing the Civil 3D command line. We have used the write message function from the editor object to write the hello world message at the command line. To be able to debug our application, we need to use the start external program and specify the Civil 3D executable. That is, in our case, is the acad.exe file under the Civil 3D installation folder. Now let's build the application. The application is built successfully without any compilation error. Now let's debug the application and start Civil 3D. So before we call our custom command from Civil 3D, let me add a breakpoint at this line. So using the netload command, I'm going to load that custom DLL which I have created just now, and in the choose.NET assembly dialog box, I browse to that location where this DLL is kept. Now I'm going to type the custom command name hello, which we have defined in our hello world application. And once I hit the enter button, I can see we are hitting the first breakpoint. If we continue, we hit the next breakpoint, which is calling the write message function, and that's the function which will write hello world at the Civil 3D command line. If you continue, we could see here hello world message is printed in the Civil 3D's command line. So this was a quick demonstration of how to get started with a very simple hello world type of application in Civil 3D using .NET. In the next slide, I'm going to talk about various ways to automatically load a .NET application into Civil 3D. There are various methods to automatically load a .NET application into Civil 3D during startup. Most of these are described in the ObjectRx developer guide under demand loading for .NET applications. Another approach, which is sometimes simpler, is using an AutoLisp macro. You can define an AutoLisp command to load your application and invoke the netload command to load your custom DLL. You can place this in an AutoLisp file named acad.lisp in the AutoCAD Civil 3D search path to enable Civil 3D to load it automatically on startup. This command can either be invoked manually simply by typing the custom command name on the AutoCAD command line, or fully automatically on a Civil 3D startup by implementing an auto startup macro. Okay, let's now focus on the Civil 3D .NET API. .NET API allows us to write extension to AutoCAD Civil 3D in any .NET language. In general, AutoCAD Civil 3D .NET API performs significantly faster than the COM API. Wherever possible, you should use the Civil 3D .NET API instead of the COM API, especially for longer operations, as the .NET API is a thin layer to the Civil 3D objects and has a better performance. However, at this point of time, the COM API has more functionalities, and you may find that you need to use the COM object to access some functionality or object members that are not yet exposed by the .NET API. Civil 3D .NET API functions are housed in the AECCDBMGD.dll assembly, and we need to access them through the appropriate namespaces. This slide shows you a screenshot of the Civil 3D .NET API reference document 1 page, which highlights the autodesk.civil.lan.database services namespace and lists the classes available under it. You could see that if you want to work with alignment object, this is the namespace you need to explore. This slide highlights some of the useful namespaces you need to know for accessing various Civil 3D objects and functionalities. The root object in the AutoCAD Civil 3D .NET hierarchy is the Civil Application object. It contains a reference to the current active document and information about the running product. Please note that unlike the COM API, Civil Application does not inherit from the AutoCAD object autodesk.autocad.applicationservices.application. Therefore, if you need to access to application level methods and properties such as the collection of all open documents, information about the main window, etc., you need to access through the AutoCAD application object. You can get more details about this class in ObjectRx managed class reference document. Civil document is the root object for accessing settings, styles, and Civil 3D entities. The active Civil document object is accessed by importing the autodesk.civil.applicationservices namespace and getting the Civil application.active document property. The document object not only contains collection of AutoCAD Civil 3D drawing elements such as points and alignments, but also objects that modify those elements such as styles and label styles. Collections in Civil documents are object ID collection for most objects. Objects in this collection must be retrieved with the transaction.getObject function and cast to their type before they can be used. Civil document class does not expose the underlying database associated with the document. However, you can access the database from the AutoCAD.application.documentmanager.mdi active document.database object The database object contains references to Civil 3D entities as well as the base AutoCAD entities. Styles control the display and design characteristics of drawing objects. You can use styles to efficiently manage object appearance. When you create a new object, you can apply a predefined style for its display. Later, if you wish, you can apply a different style to look it differently. You can also create new styles to suit the need of different users and different project stages. If you change a style definition, the changes are applied automatically to all objects using that style. Let me quickly mention different types of styles used in Civil 3D. You can use the multipurpose styles collection to create specific styles that can be used by more than one object type. For example, slope pattern style can be shared by gradings and corridors, and marker styles can be shared by points and survey components. Label styles are used to control and manage the display of labels, an expression for a class of objects. Labels are associated with many objects and their content is updated whenever the object itself is changed. Labels are also controlled by styles. You can modify the label styles in the same way that you modify the object styles. Table styles are used to control and manage the display of the tables associated with a class of objects. Civil 3D provides automated data tables for points, surface, parcels, alignments, and quantity takeoff. These tables provide a concise display of object data as an alternative to using object labels. The table styles control the data properties and the display component of the table. Settings apply at three levels in AutoCAD Civil 3D: drawing level, feature or object level, and command level. At drawing level, there are drawing-wide settings such as units and zone, abbreviations, etc. There are also ambient settings which affect a variety of AutoCAD Civil 3D behaviors. While these settings also apply drawing-wide, they can be overridden at the feature or command level. At feature or object level, ambient settings override drawing level ambient settings for that feature only. There are also feature-specific settings such as default styles. At command level, ambient settings can be set on a command-by-command basis. These settings override both drawing level and feature level settings. For more information on settings in general, you could refer to the topic Understanding Settings in AutoCAD Civil 3D User Guide. Document settings are accessed through the properties of the settings root object, which is obtained from the document.settings property. This object contains the drawing settings property, which contains all the top level ambient settings for the document. It also has the get settings method, which gets feature and command settings. Drawing settings and general ambient settings are in the Autodesk Civil settings namespace, while feature and command settings are in the namespace for the related feature. This slide shows the Civil 3D's drawing settings UI window, and the code snippet in this slide shows how to access the drawing settings. One of the general property called driving direction in the ambient settings. This slide shows alignments feature settings UI window. Code snippet in this slide shows how to access design speed property, which is a specific setting for alignment feature in Civil 3D. As I mentioned earlier, feature and command settings are in the namespace for the related feature, and you can see here to access design speed property, we use the autodesk.civil.land.settings settings alignment object. Let's now look into the details of how to create a style object using the .NET API. In this slide, I have shown VB.NET code snippet on how to create a Civil 3D alignment style object. Styles govern many aspects of how alignments are drawn and shown in the drawing. All alignment styles are contained in the Civil document.style.alignment styles collection. Alignment styles must be added to the collection before being used by an alignment object. After adding it to the collection object, we get the new style object from the transaction object's getObject method by passing in the object ID. Next, we set various attributes to the style object. After successful creation of the style object, we should be able to see the same in the Settings tab under the Specific Features Style collection. In this case, we added a new alignment style, and hence we can see the new style getting added under the Alignments Style collection. To create a Civil 3D object, we first look into the .NET API help file or in the object viewer in Visual Studio and look into the Civil 3D managed assembly, that is the AECCDBMGD.dll file, and find out the supported creation methods. For some of the objects, you might get different ways to create them through the overload method, and you need to select the method you want to use based on your requirement. The alignment class provides versions of the create method to create a new alignment object from a polyline or without the geometry data. In this slide, I have shown VB.NET code snippet on how to create an alignment object from an existing polyline. The version of the create method used here takes a reference of the Civil document object, a polyline options object which contains the ID of the polyline to create an alignment from, a name for the new alignment, site name as a string, land name as a string, style name as a string, and label name as a string, and it returns the object ID of the new alignment. In this slide, we can see the result of running the previous slide's code snippet to create a new alignment from an existing polyline, and the alignment is created under a site and assigned the styles and label styles as per the parameters passed in the create function. Let's now see step-by-step demo on how to create a Civil 3D .NET application and implement few commands to access the drawings and feature settings, create a new alignment style object, and finally create an alignment from a polyline. In the Hello World sample demonstration, we have already seen how to create a new project from Visual Studio template. In this demonstration, to save time, I have already created a skeleton VB.NET project. I have added some relevant comments at the beginning of this page before I start writing my code. I have also added reference to the AutoCAD and Civil 3D managed API assemblies. I have discussed about these managed assemblies and their significance in the relevant PowerPoint slide. I have also shown the steps to add them in the previous demonstration. In my skeleton project, I have a class named commands. In this class, I have added few commands. These are the name of the commands or the custom commands I have added here. I have also added sub, which will be called when we run our custom command. So let's now start writing the code. Instead of writing each single line, I'm going to do a cut and paste to fill in the code for each of these custom commands. Let me start with very first one, that is for the command name info. This sample shows how to access the basic details in a Civil 3D DWG file using the .NET API. In the code, we first get the editor object for the active document. Then we get the Civil document object from the Civil application object active document property. Civil document object contains collection of Civil 3D drawing elements. We want to find out how many surfaces, how many sides, and how many alignments are there in a particular Civil 3D drawing file. If we look into the Civil 3D.NET API reference document, we'll see Civil document class has member functions like get surface IDs, get site IDs, and get alignment IDs, etc. And they return a type of object ID collection. Once we get the respective object ID collection object, we can easily find out how many numbers of surfaces or alignments are there in the drawing file from the count property of the object ID collection object. Next, using the editor object's write message function, we are going to write a string message at the Civil 3D command line. Now let me complete the code to access drawing settings using the .NET API. To recap from my PowerPoint slide, drawing settings and general ambient settings are in the autodesk.civil.settings namespace. We need the Civil document object here. Civil document object's settings property returns setting root object, which has a property named drawing settings. From settings drawing, we can access the exposed properties like ambient settings, unit zone settings, abbreviation settings, etc. I am using a transaction object which is instantiated from transaction manager's start transaction call. I'll also need the editor object to write certain string message at the Civil 3D command line. I want to first find out what is the default driving direction value for a given drawing file. Next, I'll check if the driving direction value is not equal to the right side of the road. Then set it to the right side of the road. If the default value was already set to the right side of the road, then confirm the same with a string message at the command line. Driving direction setting is already set to the right side of the road. After that, I commit the transaction, and finally I dispose the transaction object. In a similar way, we can access a feature settings. As I had mentioned during the presentation on drawing, feature and command settings, feature settings are in the namespace for the related feature. Suppose we want to check what is the default value of the design speed for criteria-based design options of alignment feature, and then we want to change the default value of the design speed to a specific value for a particular project. We first need to get the feature specific settings object, and in this case it is the alignment settings. Using the get settings function from Civil Documents settings root object, we can access feature and command settings. Once we get the settings alignment object, we can access and manipulate many of its exposed properties. In this case, first we check what is the design speed value set to, and then we assign a different design speed value, and finally again we commit our transaction. Let's now complete the code to create a new alignment style. Here we first declare variables for the alignment name as a string, alignment style ID as an object ID, and another variable for the alignment style object. Next, we check if the style by this same name already exists in this drawing. If that doesn't exist, then we proceed to add a new style object using the add method of alignment styles collection object, which we can access from Civil document objects styles collections property. After adding the new style object, we use the transaction object's getObject function to get the style object to access and set its various attributes. Getting and setting style attributes for the style base object requires usage of the getDisplayStyle function. In the next few lines, I have shown how to use the same to set various attributes of the newly created style object. So here we can see we have set the visibility of alignment display style types arrow is equal to false. We have set certain colors for the style types curve. For lines we have set certain colors. We have set the visibility. Enable the radius snapping. We have specified a radius snap value here. Finally, we commit the transaction to complete the creation of the new alignment style object. Let's now see how to create an alignment from an existing polyline. The alignment class provides versions of the create method to create a new alignment object. Create method we are going to use here takes a reference of the Civil document object, a polyline options object which contains the ID of the polyline, name for the new alignment, site name as a string, layer name as a string, style name as a string, and label name as a string. Using the prompt entity options and prompt entity results object, we prompted the command line to select a polyline and then retrieve its ID and pass on the same to the polyline's option object. Next, we use the alignment class public shared method create to create a new alignment object by passing in the appropriate parameters. Let's now build our application and see if there is any compilation error. So project is built successfully. There are no compilation error. Let us now start Civil 3D and run each of these custom commands to see if they are working as designed or as desired. First, I am going to load my custom application using netload and browsing to the appropriate project location. I load my custom application. Next, I am going to open one of the sample drawing files from Civil 3D Tutorials drawing folder. Let me set a few breakpoints at different locations in our code so that we can debug through our code when we run our custom commands from Civil 3D. Let me try the first command, which was called info. I can see we are hitting the breakpoint set inside the sub, which was associated with this custom command info. So let me continue, and I could see here in the Civil 3D command line we are getting the details about the surfaces, number of sides, and number of alignments available in this drawing. Okay, before I execute the second custom command, let me show you what are we going to change by this custom command. We are going to change the default drawing settings under ambient and general settings. We will change this to left side of the road and say OK. Now we will invoke our custom command PSD settings. We hit the breakpoint inside of the access DWG settings sub. We'll continue. So here we see the result of running this custom command. The default driving direction settings was left side of the road, which we set just before we invoked our custom command to check if the code is doing exactly what we wanted it to do. And then it confirms driving direction setting is now set to right side of the road. Our next custom command is going to change a specific settings in the alignment feature. In alignment features settings, there is something called criteria based design option, and the default design speed is set to 60 miles per hour. Okay, let us now try the third custom command, PSF feature settings. I can see we are again hitting the right breakpoint inside of the access feature settings sub. Let me continue. So we can see here current design speed value is set to 60. After change, design speed value is 200. Next, we are going to add a new alignment style using our .NET application. So before I do that, I have opened the collection of the available alignment styles in this particular drawing from the settings tab in the tool space. We can see there are certain alignment styles already available. I'm going to now execute the custom command to create the new alignment style. So I can see it's hitting the breakpoint set inside of the create alignment style sub. So we are going to create a new alignment style by the name demo alignment style, and we are going to set some of the attributes of the newly created alignment style. The code snippet already I have explained, so I'm going to just continue here. So after executing this code, I can see this new alignment style is being added to the alignment styles collection under the alignment feature in the settings tab. So before we try our last command, that is creating an alignment from a polyline, I have just quickly added a polyline here, because in our custom command implementation we ask user to select a polyline. So let me now try that custom command. I can see we are hitting at the breakpoint set inside that create alignment from polyline sub. So first we are going to see a prompt at the Civil 3D command line asking user to select a polyline, and for that we have already added a polyline which we are going to convert to an alignment using the alignments create function. So let me continue here. So it's asking at the command line select a polyline. So I'm going to select this polyline, and I can see this polyline is now converted to an alignment, and we can see here the alignment name has been set to the string which we have passed in, and it's using a style and label styles which we have specified in the creation method. So this concludes the live demonstration on how to use Civil 3D .NET API to create certain objects or to access different objects inside of the Civil 3D drawing. The component object model, a COM, allows an object to expose its functionality to other components and to host applications. Many of today's software include COM objects. Although .NET assemblies are the best choice for new applications, sometimes you might need to employ COM objects. MSDN has plenty of useful resources on this subject, which you can refer to if you want to learn more on this. I am discussing this topic here as we might need to use certain COM objects in a .NET application in Civil 3D, as some of objects or functionalities are not yet available in Civil 3D.NET API, but they might be already available in Civil 3D COM API. Till we get the same objects or functionalities in Civil 3D.NET API, we can make use of the COM objects in .NET application using the COM interop technique. So what you need to do to use the existing Civil 3D COM objects in a .NET application? As a first step, you will need to add reference to the COM object libraries in your Visual Studio .NET project. This slide mentions the step to do the same. You might be aware that Civil 3D COM objects are grouped in different TLB files as the land object library, pipe object library, corridor object libraries, etc. If you want to create or access a specific COM object or functionality, you could simply add the object library and UI object library TLB files for the host COM object. You need not add all the Civil 3D COM object library TLB files. For example, if you want to create a COGO point, you just need to add the Autodesk Civil Engineering 8.0 land object library and Autodesk Civil Engineering 8.0 UI land object library for Civil 3D 2011 release. You must add reference to AEC base 6.5 application library and the AEC base 6.5 object library and the AutoCAD 2011 type library. Next, you need to import the required namespaces. Carrying on the previous example of creating a COGO point, this slide shows that after adding the specific object libraries, as a next step, you need to import the namespaces to access the specific COM object or functionalities in your .NET application. As a next step, you need to get the AECC application object by using the getInterfaceObject function of the AutoCAD application object and by passing in the application name. In this slide, we can see that the application name used is ACCXUILand.ACCapplication.8.0, which will get us the land application object of Civil 3D 2011 release. The version number is specific to a release, and if you need to access the same ACC application object in previous release of Civil 3D, you need to use the appropriate version number. For example, to get the Civil 3D 2010 land application object, you need to use the ACC XUILand.ACCapplication.7.0. As a next step, we need to get the document and database object from the ACC application object from its active document and database properties as shown in this slide in the code snippet. This slide shows the code snippet on how to create a COGO point using COM object in a .NET application. Each individual point is represented by an object of type ACC point. The point object contains the identification number, description, and location for the point. We add a new ACC point object by using the add method from the ACC documents points collection and set some of the properties of the newly created or added point object. All points in a document are held in the ACC document.points property, an object of type ACC points. In this slide, we see a code snippet on how to create an ACC alignment object from a polyline in a .NET application. The ACC alignments add from polyline method takes an alignment name, a layer to draw an AutoCAD polyline entity, and alignment style object and an alignment label style object and flags indicating whether curves should be added between the separate line segments and whether the polyline entity should be erased after the alignment is created. We can also cast the ACC alignment object to Civil 3D.NET alignment object and open the alignment object using a transaction to read or write additional data to it using the functions available in alignment.NET API. In the subsequent live demonstration, we'll see how to do the same. Let's see step-by-step demo on how to use COM Interop in a Civil 3D.NET application and implement few commands to create Cogo point and an alignment. I have now created a blank VB.NET project. The default class is added by the .NET wizard. Here I want to demonstrate the essential steps to use Civil 3D COM API in a .NET application. Let's add reference to the essential or required managed assemblies and Civil 3D COM API type libraries. So first let me browse to the Civil 3D's installation directory and add reference to the required managed assemblies. We'll set the copy local attribute to false so that we are able to debug our application and at the same time reduce the disk space. Next, in the add reference dialog box, we select the COM tab and there we select the following type libraries: AEC base 6.5 application library and object library. Then we are going to work on Cogo point and an alignment object. So for that we need to add reference to Civil Engineering 8.0 land object libraries and UI land object libraries. Next, I will import the necessary namespaces to access the required objects and functions. So other than the namespaces from Civil 3D and AutoCAD's managed assemblies, we also need to import namespaces from the COM library. So now I'm going to add two custom command, one to create Cogo point and another to create an alignment. Instead of typing all the codes, I'm just going to copy and paste the relevant code to create a Cogo point and alignment. However, I will go through each line and explain you what I'm doing here. In the create Cogo point sub, at the beginning, I declare few variables for the editor, AutoCAD application object, ACC application object, ACC document, and ACC database object. Next, using the get object function and by passing in the AutoCAD.application, we get the AutoCAD application object. In the next step, using the AutoCAD application object's get interface object function and passing in the ACC x UI land.acc application.8.0, is the program ID, application name of the land application specific to Civil 3D 2011 release. We get hold of the ACC application object. Next, from the ACC application object, using the active document property, we get the ACC document object, and from applications active document database property, we get the ACC database. Next, I declare two variables, one of type ACC point, which represents Civil 3D Cogo point, and another AutoCAD point 3D type. In the following step, I am going to prompt the user to select a location in the model space or in the drawing to create a Cogo point. ACC documents points collection object has an add method which takes location as object and it returns an ACC point object. Once the COGO point is created or added to the points collection, next we set its attributes through properties like raw description, name, number, etc. And we did all these steps inside a transaction. So finally we commit the transaction to complete the creation of the COGO point. In the next example, I'm going to create an alignment using Civil 3D AECC alignment object. I have already added a custom command for that and associated sub for that command, which will be called when we try to execute our custom command in Civil 3D. So let me complete the code for the same. At the beginning of my command implementation, I declare the necessary variables and get the ACC application object, ACC document object, and ACC database object. In a bigger application, you should separate these steps and create a helper function which can be called in anywhere to get the necessary application or a document object. My custom command is going to prompt at the Civil 3D command line to select a polyline, and for that I have used AutoCAD.NET from entity options and from entity results object. In the next step, I am using add from polyline function from the ACC documents siteless alignments collection object. Add from polyline function takes an alignment name, a layer to draw, an AutoCAD polyline entity, an alignment style object, and an alignment label style object, and flags indicating whether curve should be added between the line segments and whether the polyline entity should be erased after the alignment is created. This function returns an object of type ACC alignment. In the next step, I am using the try-cast function to cast the ACC alignment object to a .NET alignment object, and also using the transaction object's getObject function call to open the .NET alignment object to write some additional data. If the cast is succeeded, I am going to add design speed at certain station using the .NET API, and for that I use .NET API design speed.add function, which takes a pair of double. First parameter is the station and the second is the design speed. So at certain stations I add different design speed. And finally, we need to ensure that the alignment design is speed based by setting the use design speed to true. So this completes the code for both of our custom command, one to create a COGO point and another to create an alignment. So let's now build our application. I can see it's successfully built. There are no compilation error. So before we launch Civil 3D and execute our custom command, let me add few breakpoints and now launch Civil 3D. So Civil 3D is launched. Now I'm going to use netload command and browse to the location where this DLL is saved, and then I load my custom application. I'll also open one sample drawing file from the Civil 3D's tutorial drawing folder. So let us now try the first command to create a Cogo point. I can see we are hitting the breakpoint inside of the create Cogo point sub. I'm going to continue here. We can see here we are getting a prompt at the Civil 3D command line. Is asking us to select the location to create a Cogo point. So if I select a location in the model space, I can see a Cogo point is created here. And if we remember from our code snippets, we had set the Cogo point number to 10, and we had also set a raw description for the same. So let us now try the second command, which is creating an alignment. We actually create an ACC alignment object from a polyline, and then we cast it to .NET alignment object, and we will add certain design speed to the same. So let's try the second command, which is scral, and you can see we are hitting the breakpoint inside the create alignment sub. Let me continue here, and as expected we can see a prompt at the command line which is asking us to select a polyline. I'm going to select this polyline, and we can see this polyline is now converted to an alignment object. Let us check from the alignments property if the design speeds are added. Oh yes, the design speeds are added to the stations which we had specified in our .NET application. Now I am sure we are confident enough to create our own .NET application on Civil 3D using Civil 3D.NET API as well as COM Interop. What's next? Where do you get useful resources to move forward? At this point, I'm going to discuss on Civil 3D API documentation. AutoCAD Civil 3D Developers Guide is designed for developers who want to customize AutoCAD Civil 3D or create applications using the underlying APIs. This resource document discusses the fundamental concept of programming in AutoCAD Civil 3D. It talks about the basic steps of getting started with .NET project settings, migrating COM code to .NET, and importantly, how to create, manipulate, update various Civil 3D objects like points, surfaces, alignments, profiles, pipes, corridors, assemblies, and subassemblies using .NET and COM API with lots of code snippet in it. AutoCAD Civil 3D.NET API reference document is another very useful reference document with code snippets which cover the Civil 3D.NET objects. AutoCAD Civil 3D ActiveX reference document is the extensive COM API documentation with lots of useful details covering the object model and various ActiveX libraries hosting the COM API. Here I would like to mention that AutoCAD Civil 3D Developers Guide is available online. AutoCAD Civil 3D user documentation and other useful resources are available from the documentation link page. So without installing Civil 3D, for a quick reference or help, you can browse through the online documentation. Let's take a look at the additional API resources we can make use of in customizing an application development of Civil 3D. In this slide, I have listed some of them. We have lots of API samples demonstrating Civil 3D API functions available at Civil 3D's installation directories sample folder. One can refer to the Developer Center page in Autodesk public website, which has concise customization information related to our platform applications like AutoCAD, Civil 3D, Map 3D, MapGuide Enterprise, TopoBase, etc. In ADN website, which is accessible only by ADN partners and members, we have variety of useful resources like code samples demonstrating some particular API functions, white papers, then we have short sessions of API training videos which we call as dev TVs. We have the recorded session of API webcast, and of course the dev help online page where ADN members can post any API related questions. I would also like to mention here that most of our API webcasts are open to public, and all the recordings of the webcast we completed till date are available for public download. Recently, one of our colleagues from DevTech team has developed a tool and accompanying DevTV session to help people migrate from their VBA code to VB.NET. If you are one of them, if you want to take a look what should be the process or steps to migrate from a VBA to VB.NET, I would suggest please visit ADN site and look for the migrating VBA to VB.NET DevTV. This DevTV is also available to all through the Interface API blog. We organize a number of API webcasts and API classroom trainings at different places across the globe. Please visit the API training classes URL to find out what's coming next, which could be of your interest. One can also visit the public discussion forums, and there is one related to Civil 3D customization. Some of you may be already aware of the few blogs which are written by our ADN colleagues, like through the interface blog written by Kane. It has wealth of information on ARX and .NET which could be useful to you. This slide shows you the number of learning resources for Civil 3D which ranges from basics to best practices. I hope some of you have already explored these resources to take the maximum benefit of Civil 3D. I hope you have enjoyed this Civil 3D.NET API training video and it is useful to you. Thank you very much, and I wish you good luck in your Civil 3D.NET application development.